Why? Do you want to conduct a vulnerability scan? What sorts of scanning decisions do you have to make and how do you run it? How do you use audits and assessments? So this past week, a guy from Lincoln who works for the Department of Homeland Security, and he works for Nebraska, he was doing routine scans of networks and discovered that there was a Fortinet vulnerability, a possible Fortinet vulnerability on the outside firewall, on the firewall in D1. Well, it turned out that the CVE was not for the firewall, but for an enterprise management system that we don't use. As a result of that, I did disable any cloud services that connected our Fortinet to the FortiCloud. We did not have the enterprise management system that the specific CVE was referring to. Our D1 was perfectly safe. Our firewall was up to date. We looked at it last week, I think, not last week, the week before, on Tuesday, and I said, yes, I'm going to update the firewall that night when nobody's on the network, and I did, which means that the firmware on the firewall is up to date. We decided after I talked to the network admin guy at WNCC that since I'm not using the cloud service, it only backs up the logs, which I never look at. At least that would give us a way to look at logs from a long time ago. I don't really ever need to do that in D1. So I disconnected that service. So there it was, a real incident, real life cycle incident. They did disconnect D1 for a while because of that, just to be cautious. And then I did some research and found out that the vulnerability was not on our firewall. It was for a piece of software or hardware that we did not use. So just let you know, those things happen in real life. And that's how you use a vulnerability scan. You use it to see, oh, maybe there's not something up to date. Let's check. That's a good way to do it. All right. So they were examining the organization's security. In this case, it was a vulnerability scan the guy from Lincoln was running across the state network, which we are connected to. We're connected to a state network, which provides Network Nebraska, I think is what it's called, that provides our internet access. So one of their baseline things they do and we do here at WNCC is ongoing scans for vulnerabilities, things that need to be updated, settings that are not quite right. He couldn't scan anything beyond what my firewall was reporting to the outside world. He couldn't scan inside my network, but he did discover that there was a potential vulnerability, which that's good. So let's look at vulnerability scanning. So vulnerability scanning can be like he did from the outside, just looking at the outside of the firewall, and you can only get so far doing vulnerability scanning there. The other type of vulnerability scanning that's common is internal vulnerability scanning. The network guy at WNCC, I think we have a dedicated firewall device that looks at everything and says, oh, are you up to date? Do you have, the right firmware? Does the OS have the right patches and stuff? So many applications that we use have open source libraries. Well, they're going on about open source libraries in here. Actually, the vulnerabilities are all over the place. However, the library, any open source library that you use or program is not controlled by a single entity. So since they're open source, anybody can contribute, and of course, then a hacker can contribute to it. I don't know from experience if open source is any more vulnerable than closed source. Closed source would be like Microsoft. Windows, they don't release the code for that. They don't let everybody work on it. But as time is going on, there's more and more open source software. So what do we do? Well, how do we identify them? What's the technical limitation? The big one is, once you find something, how do you remediate it? Well, in the case of D1, we remediated it by doing some research on the vulnerability, looking at Fortinet's website, looking at, where did I go? SANS.org or the CVE website. I went there, I did some research and discovered that we were in the clear. So threat intelligence is data collected to understand a threat actor. Some intelligence data is proprietary. Some enterprises, if you look, they have what's called a bug bounty program. So do a quick search on bug bounties. There's a lot of companies that do bug bounty programs. That means that they'll pay you if you find a bug in their software. I don't know of anybody who's ever done that. I think that's it here, Bug Crowd. Yep, public bug bounty program list. So there's all kinds of, look at here, there's all kinds of people that are participating in this. Not everybody does, but lots of people do. So there's a potential for money if you really, a little side gig if you know what you're doing, beyond my capability. All right, so there are different parts to the web. We are on the clear web. And there's a nice picture. It's just going the wrong direction. I think I'll make it bigger. So we're on the clear web. This is where we do all of our searching and Googling and AI and all that sort of stuff is up here. Now, when we're getting down to here, we're into what they call the deep web, but most of this is controlled by access controls like usernames, passwords. You have to pay for it. Organization-specific information like our stuff on Blackboard, our stuff in our student information system is all closed. So you could consider that deep web. Never really heard that term before. Dark web is where all the bad stuff happens. So if you want to take a chance and learn more than you probably wanted to know, look into the dark web. No, I'm not recommending that you look into it. It's not something even I have looked into. Not even I'm not a cybersecurity expert, but I haven't looked into it just because it is very dangerous. All right, so there are different types of vulnerability scanners. Most of them are paid for. There's intelligence sharing organizations. There's also organizations that like SANS and the CVE website that provide information open source because they want to prevent bad people. This is the U.S. Department of Homeland Cybersecurity officer. So they do all this. They do malware analysis. They look at stuff. Apparently they do vulnerability assessments too, which I didn't know. That was very interesting to go through that process. So there is open source intelligence. We have a lab today where we look at CrowdStrike's website where they show what's going on in real time on the web. It's kind of scary. There's all these attacks happening all the time. Yeah, there it is. There's just stuff popping up all over the place. There's millions of attacks every day. Or thousands anyway. All right, open source libraries are not necessarily more vulnerable. What should be scanned? Well, if you're a penetration tester, there's different ways of scanning things. It depends on what permissions you have. The gentleman from the Department of Homeland Security only had no permission to my network. All he could do was what's exposed to by the firewall to the outside interface. So let's look at types of scanning. You can scan the network. How can the network be attacked if someone can get on your network? If someone gets on your network, well then what sort of endpoint protection do we have? What sort of vulnerabilities do we have there? Can we identify rogue access points? Mike was telling me, the network guy was telling me that the Cisco devices can actually shut down a rogue access point. And by using the Cisco devices, he can see if there's extra access points going on. Database. Well, databases have to be secured. So for example, our colleague database is our student information system. I have a certain level of access to it. I don't have the same level of access that a database administrator would have. Students have different access. So part of vulnerability scanning is really hard to automate. You basically have to audit it and keep track of who has what. It's a much more manual process. So what other assets do we have in our organization that are vulnerable? Do we have an old, out-of-date browser installed on our computers? Is our student information system client software, is that out of date? There's all kinds of things. Are our certificates up to date? So you can, and I don't know if we have this or not here, but there are some places I've worked with that have hardware asset management systems where you can manually put stuff in. You can also scan the network and see what's in it. There's two different types of scans that you can do while we're talking about scans of a network. There's credentialed scans, meaning you're scanning under the context of a user who has administrative access to whatever you're scanning. Non-credentialed scans would be scans based on the fact that you have no authorization to scan. You're just looking for vulnerabilities that would show up for anyone. So if you're going to inventory hardware, you would want to have a credentialed scan to see what's going on, because that information is not necessarily easily available. However, when we looked at our Nmap scan, which is a non-credentialed scan, remember we've done those, we could find out stuff about the operating system, what's the MAC address, that sort of thing, but we really couldn't find out very much specifics about the internal hardware. We could find out what can be identified by talking to the network card and probing the outside of the operating system. If we had done a credential scan, which Nmap doesn't do, we could find a lot more detail. Now, Nessus, which we have a lab on this week, allows you to do a credential scan if you wish. Well, in this case, we're scanning our local computer from our local computer, or you can scan your virtual machine. Either way, because you're scanning your local computer and you're logged in as an administrator, you're doing a credentialed scan, so you can find a lot more information. All right, what else do we have? Software. Yep, like hardware, we need to monitor our software. Because hardware needs firmware updates, software needs Windows updates, software updates, patches, all that sort of stuff. Bad things are happening all the time. Always change your defaults. Always keep everything up to date. All right, so active scanning means we're sending transmissions onto the network. Passive scanning is listening for what's going on. So Nmap is an active scanner. It probes and pushes and finds out what's going on. And we just talked about internal, external. And it does say here external vulnerability scan is performed from the vantage outside the network. Even if you're scanning internally, you can think, well, I guess it'd be credentialed and non-credentialed. Anyway, never mind. So the Department of Homeland Security guy was doing an external vulnerability scan, and he found my firewall, which was perfectly fine. You can schedule scans. You can decide how frequently a scan must be performed. Maybe you have regulations. Maybe HIPAA says something. Maybe Sarbanes-Oxley. It just depends. The more you scan, the more resources you use, the more somebody has to look at the scans. So it costs money to scan the network and keep things up to date. And we have a lab on Nessus. This is another one that's an open source one. I don't know that it's open source anymore, but there is an educational version of Nessus that we can use. And we're going to use that in a lab this week. And I think this is Invicti. But anyway, you'll find out when you do the lab when it shows up as bad things. Let's see. So the scope of we'll look at that when we look at the assignment. So a server-based scanner technology, which is what Nessus is, because we aren't installing an agent anywhere, goes from the scanner and looks at the servers and has no inside software giving it information. Agent-based means that there's something on the computers that are sending information back to the management. And you'll see both types, and some will combine both in one thing. Talked about credentialed, non-credentialed. Credentialed scan. You should validate what's going on. His scans showed that there was a possible threat, a possible vulnerability, but there wasn't after we did some research. Let's see. We're not going to go that deep. They don't talk about CVE. CVE is the things that are the, let's look that up because I forgot what CVE even stands for. Common vulnerabilities and exposure. So a lot of this is open source. The program was funded in 1999 and the Department of DHS maintains it. Interesting. So here is the company that maintains the CVEs, and this is where I look to see what's going on and where bad things are. Oh, there's a new website too. So they're doing a transition. Anyway, there's lots of things here. You don't have to join anything. You can look in here and see what is going on. You can search the list. You can find out all kinds of things here. So this is like open source intelligence about the bad people. All right. Or the naughty people, maybe. So once the vulnerability was we discovered there was no mitigation. The only thing we did is we took some preemptive mitigation by disconnecting a cloud service that I didn't actually use. That's called hardening. If you turn off things that you're not actually using that are automatically set up by the vendor. Well, if I had been thinking way back then, and we're in a much higher security, this firewall is like 6 years old. Still works great, but it's 6 or 7 years old. I might have not turned it on in the first place. So it's good to be paranoid. You just also don't want to be so paranoid you don't get any work done either, or cause undue burden on the users. It's a balancing act. This is what's happened. I didn't have a vulnerability, but we did harden the firewall by taking out an extra connection that wasn't needed. So you always would typically you'd start with the difficult ones first. Maybe sometimes you can't update things. You may have old legacy software, an old legacy something you have to run that there are no more updates for. That happens in the medical field because FDA has to approve any medical devices. Medical devices are not always up to date. Is that a bit scary? Yeah, it's true. Because it takes so long to get through the FDA process. If you update a computer, it's not the same computer, or to the device, it's not the same device that the FDA approves. So you have to go through the process again. I found that interesting when I learned that. Let's see here. An audit is what we're doing. We're doing a security audit. An audit is just to see what the results are and are they accurate. And an assessment is a judgment about those results. So we're looking at things for accuracy. We also think, okay, so Mike and I decided it'd be good judgment to disconnect the Fortinet firewall from the FortiCloud, which I wasn't using anyway. I wasn't ever looking at those logs. Nothing ever happens in D1. I'm glad. So every company does internal audits. That's always good. Many companies do external audits. We have an external audit every year. Hospitals, banks, many businesses have external audits. One advantage of that is that your internal IT staff gets used to the way things are. Someone from the outside world can take a totally different view and find things you hadn't thought of. Penetration testing is the sexy part of cybersecurity, although it is not the biggest part of cybersecurity. A vulnerability scan, which we're going to do with Nessus, is a way to probe the network and see what's going on, but you never do that unless you have permission to do it. You don't just go out, and there are various websites and things you can do this on. You can do it in D1 if you wish. You have permission for that. You have permission on your network as long as it's your network. Otherwise, hands off. Okay, contracting, there we are. We just went through that. Active reconnaissance, yeah, we've talked about that. Active reconnaissance means that we're directly probing, like Nmap as a direct reconnaissance. Passive reconnaissance, and I think there was one in the Nmap that showed that it just listened to the network. It didn't actually send probes. So when you're looking at footprinting is analyzing and seeing what's going on in the network and what's there. Well, this penetration testing is only one way. Another way to footprint is just to dumpster dive, find out about the, what sort of things are being thrown away. Research stuff on the web, talk to people at a bar. There's all kinds of ways to footprint an organization. You're just trying to find more information about the organization. That's what hackers do when they footprint. Footprint legally means you're finding out what's on your network. So this gives the differences. Yep, we are not going to go to the dark web. So why do we do a vulnerability scan? Well, to find out if there's something we need to fix. Really. How do you run it? Well, depends on your software. We have a lab where you're going to get exposed to that. Anyway, it's a dangerous world out there. Be safe.